Okay, today we're going to look at systems of equalities, word problems. Okay, so we've been doing word problems with an equal, but this is going to involve inequalities because we're going to have various different solutions because you've got a boundary set, just say less than or equal to 5. Well, that could be 5, 4, 3, 2, 1, 0. And depending on what the situation is, if there's a negative, most word problems don't have a negative unless you're dealing with like temperature or okay. So instead of using that equal sign, you're going to have an inequality. So you kind of have to think about it a little bit more. Okay, let's just get started off here. Suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. All right, flour costs $1.50 per pound, and oatmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. All right, you remember with word problems, one of the equations usually dealt with money, the other equation dealt with the number of items, okay, or the number of hours, or time unit. All right, so same thing here. So we got cornmeal and we have flour. So let's let flour is going to be X, and this is going to be the number of pounds of flour by the pound. Let me make this pen a little smaller. And then Y is going to represent cornmeal, the number of pounds. Okay? All right. So it says flour costs $1.50 per pound, cornmeal costs $2.50 per pound. It says you want to spend less than $25. Okay? $25 on flour and cornmeal. And it said, but you need to buy at least 6 pounds. All right, so let's just deal with the money. It's $1.50 per pound of flour, which is X, and so plus $2.50 per pound of cornmeal, which is Y. All right, and they want to spend less than $25. So less than $25. So less than $25. Okay. All right. As far as the number of pounds, it says but you need at least 6 pounds altogether. So since X and Y represent the number of pounds, X plus Y, let's hop all your pounds together, need to be at least, so greater than or equal to 6 pounds. Okay? So now you've got your two problems. So we're going to graph it to get our solutions. And first we need to put them in slope-intercept form. All right, so we're going to, for this, it'd be 250 y is less than negative 150 x plus 25. So we're going to divide by 250. So y, we're divided by positive, so you don't have to reverse your sign. So y is less than or equal to negative 150 over 350. And you can reduce that. 50 will go into $1.50 3 times, so negative 3, and 50 cents will go into 250. It'll go in there 5 times. So negative 3/5 x plus 250 will go into 2.50 will go into 25 10 times. Okay, so that's going to be your new equation there. This one's going to be a little easier. You just bring the x over, so it comes minus x. All right, so let's graph this. All right, so on our first one, 10 is our y-intercept. So let's go to 10, 2, 4, 6, 8, 10. And then my slope is negative 3, 5. So go down 3 and to the right 5. Down 3 to the right 5. And you're just continuing this to the edge of the graph. Down 3 and to the right 5. All right, and it is less than or equal to, so it's going to be a solid line. Try to make it as straight as I can. All right, let's, oops, almost forgot. It's less than or equal to, so the shading is going to be below the line. All right, so now let's graph the second one. So my y-intercept is 6, 2, 4, 6, and my slope is negative 1. So down 1 to the right 1, down 1 to the right, down 1 to the right, and continue that to the edge of the graph. Okay, and this one as well is a line. You know what? This should have been just less than, and that should have been a dash line. Let me kind of, there's dash, that's better. Okay, and since this was greater than or equal to, then you're going to be everything above. All right. Okay, so our solution area is going to have the borders, solid border here, 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 and then it's going to be dash border because it doesn't include everything on that line. Okay, and then all inside here. Okay. All right, so since, and we said that x was, ooh, that's way too big. We said that x was flour, and then this is cornmeal, all right? All right, right, two possible solutions. Well, kind of covered up my area here. It's kind of hard to see inside there. Let's, oh, wow. That wasn't good. Now I can't see. All right, well, we know that, let's see, right here would be 1, 2, 3, 4, 5, 6. This would be 6, 1. And it's not 6, 2, because here's your origin right here. So 6, 1. So possible would be 6 pounds of flour with 1 pound of cornmeal. Okay. Another would be, let's do 2. It'd be, let's go up here. Okay, so this would be 1, 2, and then this would be 1, 2, 3, 4, 5, 6, 7, 8. All right, so here we could do 2 pounds of flour and 8 pounds of cornmeal. All right, so anything in that yellow area is a solution. So you could pick any point in there. You could also pick any point on this line, this solid line for this, okay? However, for this line, it's dashed, so it doesn't include that line, okay? Only the solid line can you use those points as solutions. All right, let's try another one. All right. A seafood restaurant owner orders perch and salmon. Perch is $4 per pound and salmon is $3 per pound. He wants to buy at least 50 pounds of fish, but cannot spend more than 240. So money, money, pounds, pounds. All right, so let's say that X is going to be perch, number of pounds, and Y is going to be salmon. And make sure you label those, because if you don't, and then you forget which one is which, and you start looking at your solutions, and you're like, okay, was X salmon or was Y salmon? Okay, so make sure you label in the beginning. Also, when I'm grading it, if I don't know which one's which, I don't know if you got the answer right or not, right? Okay. All right, and salmon, the number of pounds. All right, so look at money first. Perch, which is X, is $4 per pound, so per X, so times X, and, so plus, salmon is $3 per pound, and the number of pounds of salmon is Y, so 3 times Y. And it says that you cannot spend more than 240. So it's got to be less than or equal to 240. Okay? And it says that he can buy at least 40 pounds. So 50 pounds. So he wants 50 pounds or more, right? If you're going to buy at least, that's the minimum amount. So the number of pounds of perch and the number of pounds of salmon has to be greater than or equal to 50. Okay? All right, so we're going to graph these. Let's do our first one, put them in slope-intercept form. You're going to bring this over, subtract 4x, and then divide by 3. So you're going to get y is less than or equal to negative 4 over 3x plus 60. Okay? And then we're going to say this one is going to be y is greater than 50 minus x. Okay? Okay, so this equation, make it red, is 50 minus x. All right, so we said that the x was going to be your perch and y was your salmon. Okay. All right, so let's graph. Let's do the blue one. And 60 is my y-intercept. On the other one, 50 is my y-intercept. So we're going to say that each of these is 10. All right, so 20, 30, 40, 50, 60. So this is 60 here. Okay. And we're going to go down 4 and to the right 3. Okay, so you're saying, how do we do that if we counted each block as 10? All right, well, just isn't -4/3, isn't that the same thing as -40/30? All right, I just reduced it. Okay, so based on scale, -4/30, when you're doing by tens, 40 going down 40, the right 30 is the same scale. It's the same slope. Okay. All right, so we're going to go down 40, 10, 20, 30, 40, and to the right 30. And then we'll go down 40. I don't have any more room, but it's going to be about right there. Now this one is a solid line, so we're going to do a solid line. Okay, and then the red one, the slope is -1/1. So we're going to say that's -10/10. Same thing, same slope. Okay, so my y-intercept's 50, which is here, and we're going to go down 10 to the right 10, 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 down 10 to the right 10. All right, so this line as well is solid, and it's just going to be right on the outside. I can blow that up for you a little bit. Okay, it's going to be right on the outside. Now the blue one, it's less than or equal to, so that meant that the blue is under, right? So we're going this way. And then the red was greater than, so the red is that way. So when we blow that up and look at it, our solution is going to be with the boundaries here, here, and at that where they intersect right there is where that ends. Okay, this part down here is not the solution. Okay, because the blue started here and the red started here, so there was nothing in between. So everything in here could be a solution. All right, so we know they're going to ask us for 2, so while we've got this blown up a little bit and Miss Lane can see a little better, let's see if we can find us a solution. All right, so we could say, let's see, we could say this is 10, 20, 30, 40, 50. Okay, so we could say 50 pounds and 10. So we could say 50 and 10. The line's solid, so you can go on that line. And then we can also say 20 and 30. Okay. All right, so 50 and 10 and 20 and 30. $50 and 10 and 20 and 30, right? All right, so 50 of, and we said the salmon, and make sure you look at where your 50 was. It was on the salmon side. And perch, 10 pounds of the perch. And then we went down here and we did, where was it at? We did 20 of the perch and 30. 20 of the perch and 30 of the salmon. Now, Do you notice what I did? I did not write these in XY order, like an ordered pair, did I? And they didn't ask us to write the ordered pair, or just possible solution. So technically I could get off not doing that. Okay. You know, they really could have given y'all a little nicer area to graph. I guess I could have counted those as 5 instead of 10 as well. So yeah, you have to kind of look at your graphs and figure it out. Let's see. Let's flip over to the other side. Okay, let's look at number 5. A clothing store has a going out of business sale. They are selling pants for $8.99 and shirts for $3.99. You can spend as much as $60 and would like to buy at least 2 pair of pants. Okay. All right, so we have shirts, and those are going to be, excuse me, pants is first. So we got pants, and we're going to call that X. And this is the number of pair of pants. And then Y is going to be the number of shirts that you buy. Okay? Make sure you do that. I can't emphasize that enough, y'all. All right, so let's go shopping. All right, so it says you can spend as much as $60. So we're dealing with money here. So let's remember our money. Our pants. Okay, our pants, they're $8.99 and our shirts are $3.99. Now, $8.99 is 1 penny away from $9, isn't it? And $3.99 is 1 penny away from $4. So, for the sake of graphing, and if you were doing this on the computer and was doing a graph report on Excel for your boss, you would put in $8.99. The computer can do that. If you're just doing a simple graph like this, rounding it to the whole number is not going to be a sin. Okay? All right, so we got $9 per pair of pants, which is X, and $4 per shirt, which is Y. And it says we would like to spend as much as, so if we're spending as much as, okay, so if as much as, let's see, how can I say it? Oh, wow, I get to spend as much as $100 today. So what do you think? Yeah, that's as much as I can spend. Okay, so I've got to spend less than or equal to $60. Okay. All right, for the number of items, it says you need to buy at least 2 pair of pants. All right, at least 2 pair of pants. So have you ever had your mom say, here's some money, I need you to go to the store, and she gives off a list, and she said, well, I'll tell you what, you better at least come home with this. Whatever you spend that money on, I don't care, but you better at least come home with this. And you knew that, all right? You better at least buy 2 pair of pants out of that money, all right? So we're just talking about pants, so we're just going to use X. Well, she didn't say a word about shirts, okay? So pants, I need to buy at least, so more than or equal to 2, okay? All right, so let's put these in slope-intercept form. We're going to bring the 9x over and divide by 4. So we're going to have y is less than or equal to negative 9 over 4x plus 60 divided by 4 is 15. All right. The x is greater than or equal to 2. That's one of those special lines. It's a vertical line because it's crossing the x-axis at 2. So let's go ahead and graph this one. This one's easy to graph. Just draw a vertical line crossing 2 on the x-axis. Now, it said, your mom said you better buy at least 2 pair of pants, so she means 2 or more, right? So more would be 3, 4, 5, so that's going this way, okay? All right, now let's graph the blue line. My y-intercept's 15. Well, 15's all the way up here. And go down 9 and to the right 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 1, 2, 3, 4. So right here. And I don't have enough room to go down another 9, so it'll be somewhere over here. All right, we've got a solid line here, so that means my line's going to be solid. Just try to draw it as straight as you can. And this is less than, so that means below, right? Below the line. So we're going to be looking at this way. Okay. All right, so where they overlap, my boundary, this is a solid line, right? So my boundaries, I can include this. I can include this since they're both solid lines. And I can go there, right? I am not going to fill that in because we need to get some possible solutions. And let's label, oops, we didn't label our axis. So X was pants, and this was Y was shirts. Okay, so possible. So let's pick right here. Okay, so this would be, if we want to use this point, remember this is the origin, all right? This is the origin. So here's where 1 is, and here's where 1 is right here, okay? So 1, 2, 3, 4. So this is 4. And then 1, 2, 3. This is 3. So I could buy 4 pair of pants and 3 shirts. So you see these solutions in here in this triangle, all your possible solutions. Think of it like shirts and pants. It's all your different combinations of the number of items you could buy. All right? That's why inequalities have so many solutions, because it's all these different combinations you could come up with within the variables, in the parameters you have, within those boundaries that we drew just then. Okay? All right, let's pick on up. Let's pick right here. Okay? So this would be 3. So 3 pair of pants, and then 3, 4, 5, 6, 7 shirts. So 3 pair of pants. And because the shirts are cheaper, I could get 7 shirts. And Mama said I had to buy at least 2. So, but if I buy 3, I can get 7 shirts. Okay? All right, I am gonna save this last problem particular because it's got some few more questions on it for class tomorrow. And for my virtual kids, when you're reading these last questions here, it says, suppose we decide on attending 4 baseball games. What is the range of soccer games? So you would just go to 4 and go into that area of solutions and find your answer. Okay, so think of it that way. Remember when we were looking at if X is this, what is Y? That's what you're doing. All right. All right, y'all. Y'all have a good evening. And for my face-to-face kids, I will see y'all tomorrow. Hopefully I'll wake up in time. All right. Bye.